Welcome to a new PYTHA tutorial in which we will look at Boolean operations. PYTHA offers various powerful tools for combining parts in order to create new shapes. This makes it possible to model solids that have a significantly more complex geometry than their original objects. As soon as two or more parts penetrate each other, Boolean operations are useful. These include various tools. For example, you can use one tool to glue several parts together. Another can be used to drill holes into parts or form the intersection of parts. In all cases, a new geometry is created that no longer has any part overlaps. I would like to explain the commands using a simple example. First, I will draw a sphere at an arbitrary position. I enter 600 millimeters as the radius. Now I copy the sphere in the positive z direction. I pick 2 points to define the distance and the direction of the displacement. The result is two separate parts that penetrate each other and can have their own attributes, such as materials. If I deactivate the solid mode, then you can see that the upper sphere extends into the lower sphere. However, the two parts are not connected. They can be moved and edited separately at any time. Using Boolean operations, we can now combine the two parts to create a completely new shape from the two individual spheres. You can either activate the available functions in Tool Menu 1, or you can use the cheese icon above. The vertical menu now shows us all available Boolean operations, as well as some special functions for particular cases. Let us first look at the union command. As the name suggests, we can use this to combine several parts into a new overall part. As soon as I have activated the function, PYTHA wants to know which parts are to be united. I select both spheres and confirm the selection as usual with the middle mouse button. The two spheres are immediately merged to form a new part. Although the solid mode is still deactivated and I can see into the parts, the overlapping area of the two spheres has disappeared. A joint seam has been created at the position where the two spheres originally penetrated. We can now edit this using the Fillet command in Part Tools 1 menu, for example, to create a smooth transition. This would not have been possible before with the two separate parts. Please do not confuse the Boolean union with the group command, which is also available in PYTHA and can be found in the Attributes menu. Grouping is only a loose connection of individual parts, for example, to select them more quickly or to display them as a bundle in the parts list. With the Boolean union, on the other hand, the individual parts are firmly connected to each other, just as if you were gluing or welding two workpieces together in your workshop. I use the Undo button to undo the last steps so that I get the two individual spheres again, which penetrate each other. Now I activate the Intersection command in the vertical menu. This Boolean operation calculates the common volume of all selected parts, in other words, the overlapping area or the average, and creates a new part from this. As soon as I have activated the command, PYTHA asks which parts are to be edited. I select both spheres again with a left click and then confirm the selection with the middle mouse button. The spheres disappear immediately and their intersection is displayed as a new part. Of course, you can also apply this command to more than two parts. For example, if I rotate copy both spheres around their center. And apply the intersection command again, this shape is created. Again, I use the Undo button to undo the last steps and return to my two individual spheres. Next, I use the difference function. The Boolean difference is an operation in which the volume of one part is subtracted from the volume of another part. This means that parts create holes, dents, or niches in other parts. With the previously used union and intersection commands, it didn't matter how many parts I selected, and the order of the part selection did not matter either. However, this is different with the difference command. You should therefore follow the instructions in the query field. In the first step, this prompts you to select the part that is to remain as the body. I now left-click to select the part that is to remain in my project. In other words, the part into which I want to press the holes. As I can only select one part at a time at this point, I do not have to confirm the selection with the middle mouse button. The query field immediately asks the next question, and now wants to know which parts should be subtracted from the previously picked part. I select the top sphere. You can see that the query field still shows the same prompt. This is because I'm allowed to select several parts at this point, so I press the middle mouse button to confirm my selection. PYTHA then calculates the resulting new part. You can see that the upper sphere has pressed a dent into the lower sphere. The volume of the upper sphere has therefore been subtracted from that of the lower sphere. Let me summarize once again. The Boolean difference is used to create holes in a part. In one work step, you can punch holes into only one part at a time. However, any number of parts can be subtracted from this part, the body. For example, any number of holes can be drilled into a panel in one work step. The order in which the parts are selected determines which part is to be processed and which parts form the holes. The last Boolean operation in the vertical menu is called template. This command uses a 2D face as a template. Just like in reality, the template pierces all selected parts. A hole is created that has the cross-section of the template. To demonstrate the command, I will first switch to the Faces menu to create a template face. Here I use the shamrock command. I simply confirm the values suggested in the dialog. I use the cheese icon. I get to the menu of Boolean operations. There I activate the template command. As with the difference command, the order in which the elements are selected also plays a role here. I therefore pay attention to the questions in the query field again. First, I should select the parts that will remain in my scene, in other words, the parts into which the holes will be punched. In my case, this is the sphere. As I am allowed to select several parts, I have to use the middle mouse button to confirm the selection. In the next step, I am asked to select the face to be used as a template. As soon as I have selected my shamrock, the query field jumps to the next question. This is because you can only use one template per step. PYTHA now asks me whether I would like to keep the part of my sphere that is inside the template face. In other words, the material that the template cuts out of the base part like a cookie cutter, or whether I want to keep the outer part. In other words, the sphere with a hole. I have to enter 0 for the first variant and 1 for the second. I enter 1 and press Enter. As already mentioned, the template can pierce several parts at the same time. Let's take a look at this application as well. To do this, I have copied the sphere horizontally and vertically, and used the Face menu to draw a circle that I want to use as a template. Now I copy these parts by 3,500 millimeters along the x-axis. For better clarity, I now assign a new material to the spheres that I have copied. I activate the Template command again and select all blue spheres as remaining parts. I use the circle as a template. By entering the number 1, I define that I want to keep the area outside the template. Press the Enter key to remove the unwanted area of the spheres. I repeat the process on my copy. This time, however, I enter a 0 to keep the inner area of the template. Again, the punch has removed the superfluous area of the spheres. I now move the new parts minus 3,500 millimeters along the x-axis, which is back to their original position. You can now see very clearly that the newly created parts fit together exactly, as they were created using the same template face. One of the most important applications for Boolean operations is the creation of wall openings for doors and windows. To do this, you model a part whose width and height correspond exactly to the required wall opening. We just call it our Boolean part. The depth should be chosen so that the Boolean part protrudes slightly from the wall on both sides. As shown above, use the difference command to remove the Boolean part from the wall. Please also remember, if you push the Boolean part just a little way into the wall, you can create niches of any depth. By the way, PYTHA library elements as doors and windows already have a Boolean part to create the matching hole in the wall. These Boolean parts have the special part name minus. As soon as such a part is dropped using the drag and drop command or the clipboard command, PYTHA automatically performs the Boolean operation difference. The part with the name minus then directly creates a corresponding hole. This means that you do not have to call the Boolean operations yourself. Tip: you can easily change the size and position of holes and indentations in PYTHA using the move points or extend command. With both commands, you can work interactively, as I am doing here, or enter exact numerical values. In our previous examples, we only applied the Boolean operations to 3D parts, but of course you can also use the commands to edit 2D faces. I hope you enjoyed drilling holes and gluing parts, and I look forward to seeing you again in my next tutorial.